Hello guys, my name is André and I will present the paper SpotFlow, Tracking Method Calls and States at Runtime. Understand the runtime aspects of a software system is fundamental for several software engineering tasks, for example, software testing and code comprehension. However, despite the importance of runtime analysis, a few tools have been proposed and made public to support developers extracting this runtime information about software execution. To overcome this gap, in this paper we propose SpotFlow, a tool to ease the runtime analysis of Python programs. Here we provide an overview of SpotFlow. First, SpotFlow executes and monitors a Python program and collects detailed information about method calls and states. Second, SpotFlow collects data at the method level for every method call. This is an important feature of SpotFlow, as we'll talk later. For example, it collects data about the executed lines, argument values, return values, or even raised exceptions. Third, SpotFlow can directly detect what classes, methods, test methods, or even calls run which lines. This is a fundamental difference to typical tracing tools, which basically works at the file level and can only detect what files run which lines. SpotFlow can be run from the command line and it is publicly available at GitHub. SpotFlow collects detailed information about call and states. For example, here we can see the monitored method and calls and also the monitored states, specifically argument states, return states, exception states, and also states related to the variable values over time. For example, consider the application and the tests presented in the left side. This is a simple application that only counts the uppercase words in a text, and we have two tests for this method. Test 1 provides the input A, B, C, and D, E, F in uppercase, and test 2 provides the inputs A, B, C in lowercase. Basically, after running SpotFlow, we would have this output that is presented on the right side. Here we can see the multiple objects that are exported by SpotFlow. For example, we can have access to method and call states. We can have access to the executed lines of code. Here it's important to note that is the executed lines of code for each call and not for each file. We can also see the variable values over time. For example, the counter variable has 3 values over time, 0, 1, and 2. And the word variable has 2 values over time, ABC and DEF in uppercase. We foresee some applications for SpotFlow. For example, it can support the creation of novel empirical studies on runtime analysis. It can support the development of novel tools in the context of software testing, and it can also support the creation of novel datasets with runtime metrics. In the following slides, I will present real examples of these applications. First of all, we have used SpotFlow to monitor the execution of over 14,000 tests provided by the Python standard library, and we have detected that one tested path is prevalent and receives most of the calls, while other paths are much less executed by the test suite. As a second empirical study, we have used SpotFlow to provide this approach named test polarity. Basically, this is an automated approach to detect positive and negative tests in test suite. We have analyzed over 2,000 tests of the Python standard library and we have detected that most of the tests are negative, 88%, and only 12% are classified as positive. We also used SpotFlow to support the creation of novel software testing tools. For example, we proposed Path Spotter, which is a tool to explore the test paths of an application to discover missing tests. We have used this tool with success to improve the test suites of relevant systems, for example, CPython, PyLint, and Jupyter Client. We also foresee that SpotFlow can be used to support the creation of novel datasets with runtime metrics. For example, we have proposed Test Dossier, which is a dataset of tested values automatically extracted from the test execution. This kind of dataset can be used to better understand the tested data and support the test improvement if needed. In summary, SpotFlow is a tool to ease the runtime analysis of Python programs. It collects detailed information about method calls and state. It can be used to detect what classes, methods, test methods, or even calls run which lines. SpotFlow can support novel empirical studies on runtime analysis, the development of novel testing tools, and also the creation of novel datasets with runtime metrics. Thank you very much for your attention, and feel free to contact me if you have any further question about SpotFlow.